Aha, I'm recording. Well, we got 5 people on this time.
All right, let me just put a message in there.
So we go in the chat.
Yeah, hang on.
I mean, I think we pretty well concluded we can show a little bit. I guess I can just keep on going if more people want to see more. Start from the day in the life of an account. Go into a little bit of the lattices.
All right. Yeah, I might not have too much longer I've got here anyway, but just something I wanted to point out before you carry on with the demo was the use of session and our idea that you will only require a session ID if you are. Let me shut my door. You're only going to require a session ID if you configure your node to want to use session-based APIs.
Yep.
And by default, we probably won't. We're still deciding on this, but we probably won't. And that session is just sort of kind of managed for you in the background.
Yep.
So for just a single seat user, somebody wanting to interact with their wallet via the API, they're not going to need to worry about that session ID.
Yep. And the point of the sessions is for if you want to manage your own accounts. Generally, it's also for existing services. Let's say somebody wants to run a consumer verification service on their own private chain. And integrate that directly with their login system. That would be something that they could cache in their system and then be able to give a user access to their SIG chain inside of an existing web service. So that's another aspect of it, since they already store credentials for a user account. That's another use for the Sessions API. But for like more of a DApp, lack of better words, or a distributed application, what it's going to basically do is you're going to run your node in light mode. And just log into your session there and just broadcast your transactions to the network and manage your keys there, so that you have a local only login where you only log into significant SIG chains on your own. So a lot of different options that are capable with these sessions and these logins for a lot of different purposes. You generally have to have a wallet in order to access that, and that's going to be the same type of thing. You're just going to have a wallet that runs in light mode that you log into, and you create your transactions on and broadcast those transactions to the network, or be able to claim your ownership of those specific digital assets. So just to clarify that, so you guys can kind of understand a little bit more of the security precautions that go into this as well. It's kind of a hybrid system that allows you to use it for whatever suits your purposes. So I guess I shall continue with the demonstration. Anything else you want to add, Paul, before we get moving a little more?
No, it's fine. Jump right in. I might try and just keep track of what you're doing and moderate a little bit, just so that people can understand what's going on.
Okay. So everybody can see my screen. Oh, there's the Zoom video. Okay, so here we still have our testnet node. So this is just running in my own network. Now, since we've been making a lot of changes, you can actually fire up your node with testnet equals and just create your own testnet. So testnet equals 8, testnet equals 9. This is testnet 8, just because I like that number. Anyway, so let's go over here. So this now we can see. So let's do accounts transactions. Username equals, this guy's Colin, but the cool thing about it is if you know your specific username, this shows my specifics. So this is the register operation. Those are creating assets, debits, credits, debits. I think I have a couple transfers in here. There's a transfer. So for a quick, I guess, idea, let's go into here and let's say accounts create. So I'm going to make a username. What should I call this one? Let's call it viz2. Password equals password and equals 154. That's your generic. So now we're going to see a big transaction object return. So, okay. So now this you're going to probably see as well. These signatures and public keys look a little bit bigger than usual. The reason on this one is I wanted to just demonstrate the use of our lattice-based cryptography here. So this specific testnet is actually using what is called Falcon, which is fast Fourier lattice-based signatures over NTRU. sounds complicated, but basically it's second round candidate. So it just got through the second round for NIST. And it's actually the most compact signatures. And the nice thing about lattices too, the reason I'm using them in this test net is the computation requirements are at least 1/40th of ECDSA, which means you can verify signatures very, very, very fast. So that means our 4,000 transaction per second bottleneck on the LLC now is much, much, much higher. Now, you do have a trade-off of a higher amount of disk requirements with the public key and the signature. Obviously, they come together about 1.4, 1.5 kilobytes. But the reason that I've just been demonstrating this here is just to kind of show the use of it and show you guys that it's actually working rather than just being an ECDSA. So another nice thing about Falcon and lattices is that they're fully quantum resistant. So EC keys are vulnerable to quantum attack. That's where signature chains actually prevent that, because this next hash is actually the next key that can spend in my transaction chain. And the public key is not known. This is only known to me because I created it, but this is actually private until broadcast. And so once I broadcast it, then if this were ECQ, it would be vulnerable to a quantum attack in a window of about 30 seconds. With these, it's not vulnerable to any sort of quantum attack. And this holds about the same security. This being a 512-bit Falcon key, it's the same securities of a 2048-bit RSA key. So it's a comparable classical and quantum security, and extremely, extremely fast in the processing time, which is the reason that I've started experimenting with them, is realizing that computational bottleneck. In other words, sharding computation is much, much more difficult than sharding data. And also the fact that your signature chain is your signature chain. We don't necessarily have to keep around all of this data. We can discard it over time to prune it out. So you'd really only need to start keeping some of these basics here. But anyway, I just wanted to show this. So here's my account. Now, this account is now able to be logged in. So I'll do accounts login. Username equals viz2. Password equals password. PIN equals 123. I'm going to just show you. This is going to be a failed authentication, obviously, because my PIN is 1234. So this actually fully validates your authentication data to make sure that your key that you're producing in your signature chain is actually the key that generates this next hash. So that's where you get a lot of nice security parameters, is because your next hash has to be linked, which means in order to make a transaction, I have to prove that I actually know the data that made this next hash, which is this or the next public key. Anyway, and I'll show you those public keys if we want to get a little bit more verbose. But it also, the signature here, since we abstract that essentially away and we decouple your keys in a signature chain, the signature is only there to secure this transaction through transit over the network. Once it's basically confirmed, the signature is no longer needed. And the nice thing about it is these keys can only be used once. So even using these Falcon keys right now, it actually carries extremely high security properties, because you can't run side channel attacks because you're not actually using the same signature or the same key more than once. So you have less data that could be potentially leaked, which is what usually happens in side channel attacks. With Bitcoin using SECP256K1, they found that you can actually start to reveal some of the secret data of a private key with a little under 200 signatures. And then there's also the other issues with reusing the same nonce, which gives you duplicate R values, which actually people have been able to steal Bitcoins directly out of accounts. So reusing keys, I think, is a big problem, but then keeping the state of all those keys is a bigger problem. So over here, we're logged in, right? Now, just to show you, I guess, well, they're all on the same one, but this is still pointing to the same node, but I can actually log in from any node now, as long as I know my credentials. So it doesn't really have to keep the state. Now, if I go here, API, accounts, transactions. Now I can do this by username, so I don't have to constantly keep track of this Genesis. It takes a little bit longer because I have to actually generate this. Since we use Argon 2, it takes quite a bit of time to actually generate these hashes, which prevents anybody from offline password cracking. Like I was saying earlier, it takes your time from potentially years or months to decades, since really you can only generate one of these hashes regardless of how much computing power you have, over about 300, 400 milliseconds. So I think what I have is sense. So that's like 2 to 3 guesses per second. Anyway, showing the transactions, let's just show, this is going to show them in kind of a condensed format, but this is kind of where he shows a little bit more of the data, verbose 1, verbose 2, where it actually gives you the full signature data. Anyhow, so let's make Viz2 do something. So now that we have my session ID, this is using session, since this node specifically right here now has a login from Viz, Viz2, and Colin. But let's go over here and API assets/create. Now, let's see. Let's make this asset named Viz2 asset. Let's make the data. This is now session. Obviously, we have to paste that in. Pin, you are required to put that in every single time as a matter of security, unless you use the unlock option, which right now we only have enabled for if you're mining. That's where I have another node over here on that computer actually doing the mining for me so that this guy can just be receiving blocks. Anyway, so we're creating this asset. Now, you see it takes a little bit of time. Now, this is the asset address. So to the network, this is the address that people see. So if I want to go over here, if I don't know that this asset is named Viz2, I do asset/get address equals, and there we go, we see this. But what's also nice is I can do asset/get name equals Viz2 asset. I get the same thing. This is my asset. Here's my owner. See, and the network, as you know, doesn't know that this is Viz2. Nobody really knows who's who. But if I tell Viz over here that this is Viz2, or I want to transfer and I know, and I don't want to keep track of all these genesises, I can do a transfer operation. So what I'm going to do over here, I'm going to do an asset/transfer. Grab my session. Oops. So I have to delete this. Forgot I had that copied. Okay, session right here. Do pin, and I'm going to say, what was it? Username equals this. Now what's going to happen here is, oops, sorry, name equals Viz2 asset. So I'm going to transfer this by name rather than by address because it makes it much easier. So as you can see here, I have actually conducted the full transfer. Now the nice thing about assets is you can actually see the history. Let's see, /history, name equals Viz2 asset. Now we see the owner has actually changed hands from Viz right here to Viz2, or Viz2, sorry, to Viz here. Now, this guy over here is the one that has specific ownership of that asset. And he is the one that can able to be transferred back. If I try to transfer it again, it's obviously going to fail because I don't have the specific rights to that. As you can see over in this log here, I'm not authorized to transfer this register, if you can see that, because I'm no longer the owner. So only the owner has these types of permissions. So an asset in this case is essentially your ability to create any sort of non-fungible token. Now, as I showed earlier, we have the fungible token. So let's see, /notifications. Actually, I don't think this one has any. Token/get type equals name equals Viz333. I believe that's what it was. Yep. Okay, so this is my other token account in the name of Viz. Now these are all globally accessible unless I have this address. So this specifically here is actually resolving to one of those addresses so somebody can see. So now we have tokens/get type token name. I think it was token 333. So this is the actual token contract here that represents the ownership. Here's the max supply, 1 million. And you can see there's 999,000 that are currently available to be sending from this. So there's only about 1,000 that are actually distributed out into the wild. So, I mean, in order to conduct an ICO and STO, you'd simply just do a tokens create. So as I was showing earlier, say type equals token. You can only use an identifier once. Name equals token 555. Session equals n equals 34. Supply equals, let's make ultra valuable one. That's needed. There we go. So this is going to come through. It got accepted to the mempool. Should be processed now. So boom, that's as simple as it is to launch an ICO. Then obviously you're going to have to do your debits and your credits to other people for anybody that wants to specifically own it. But now the cool part about this too is that the asset itself can be owned by a token. So when this token here, if you wanted to make this a more securitized token, what you do is you'd actually make this token's address, or right here, actually be the hash owner of the register. Which basically says that if you ever want to have dividend payments, then your account that may hold the amount of tokens by this identifier number is capable of claiming. Now, that's the first step as far as distributed revenue coming into it. But the next step from there is actually voting, so that you can vote and create a type of DAO scenario where if this specific token owns a Nexus account, then the Nexus transferred into that Nexus account are going to require proofs or these types of people to allow that money to move, which is going to create a valuable DAO, which we say, 50, 60% of token holders have to vote and authorize or do an authorize in order for that token or that Nexus to be able to move out of that account. And that's where I think DAOs are going to be really, really cool, because then you're going to actually have crowdfunding where token holders actually have the ability to control the spend of the money. Rather than the money just being at the trust and whim of the token creator and the issuer. So I believe I can reiterate a little bit over here. Let's say this is Viz2, this one's Viz, sorry, to keep track of all these different accounts I got running. Let's pull this. So let's go over here. API tokens create type equals account identifier equals 555 session pan equals 1 2 3 4 and name equals biz 555. All right. So now what I just did is I created an account. So I'm going to verify that it exists right now. Type equals account name equals biz 555, and you see this is an identifier. So this is able to receive tokens now. So from this account over here, token/debit, I'm going to create a debit to biz.
You got a typo.
Hmm?
You typed API wrongly.
Thank you. See, this is what happens when you code with other coders. You're like, you miss a semicolon. Sorry, little humor bodes well. All right. Let's see. So now this was created with this session. Tokens. And I'm going to say name from equals token 555 name to equals biz 555. So I'm sending from this initial token account to biz amount equals, let's say 500 of these tokens. Session n 1 2 3 4. Okay, this should execute. Now here's my TXID. Now what's cool about this too is normally you have to rescan right now, right? So if I over here just decided to log into another node, I'd have to rescan on that node, and then you just have so much computational bottleneck. So what happens right now is the operations layer actually creates an index key so that I over here check my notifications with Viz2, and whoops, I have a typo then. You didn't catch that typo, Paul. All right. So this is, oops, no notifications available. So we gotta wait for this transaction to process. Let's see. Wait, is this guy in the Viz account? I think it's just regular Viz, my bad. So regular Viz over here. Okay. Yep. Okay. I had the wrong account. That's why I wasn't seeing it. So this is showing up right here. Timestamp. This is the actual TXID hash. And then this is the operation sequence that was executed. As you can see, it was executed for this register address. And the amount was 500 tokens transferred to this account. So what I do is Viz over here is, for one, I need to make sure I have the correct session ID, which I believe was this guy. So I'm going to go Nexus, tokens, credit, TXID. Oops. Let's just do session first then. Actually,
hey, Colin, did you explain what the notifications were and why we have them?
So the notifications are a way for you to see things that have happened that are related to you, but they are not on your SIG chain. So these transactions and notifications were executed by another user that have to do with you. So the cool thing about it is we don't have to rescan anymore. Normally, the reason you rescan in the current network is because you have your list of keys and you need to scan every single transaction to see a transaction that has your key. This basically, being account-based, it allows you to just check your notifications yourself to say, okay, well, I had this debit happen directly to me, which is something to trigger you to send a corresponding credit operation to say, I am claiming this as Viz into my account that it was addressed to. So this should be, okay, yep. So this would be the right Viz session for name 2 equals Viz 555. I believe that's the name of this account I created. Yep, an amount. I have to correspond to the correct amount. Now, if all goes well, oops, I forgot the API flag. Sorry, guys. That one was actually going to the RPC, which that's why I don't have any credentials stored in this specific node right now. So you shall wait graciously as my cursor approaches the beginning of the statement. Let's see. There we go. So now here's the next TXID that I have claimed. You can see it was accepted into the memory pool right here. So hopefully the next block that comes through is going to accept my transaction. A. All right. So now what's going to happen is when I go Nexus API token / get, say name is 555 account. There's my new balance, which I have successfully credited to myself based on that corresponding one. Now, this is really kind of some of the basic primitive operations that are running in the API right now. As I suggested, next week, I'm going to be showing split dividends, split royalties, which would be for a musician or for a securitized token offering or anything like that. But this is kind of basically how some of the API works. So for the end user, as we get closer to having the mainnet release, you're obviously going to be clicking buttons rather than doing all this. But as a developer, you're going to be kind of dealing with these things at a logical layer. If you want to deploy tokens, deploy assets, transfer, have the audited, and basically be able to see all these different things that are associated with an account. If there's any questions, I think now would probably be an appropriate time to ask them.
Yeah, there's actually one that Mercury Miners put in the chat, which is, can I create a token and have it backed by an asset? I think you may have already answered that and shown how.
Yeah, what you do is you actually make the asset owned by the token itself. So that's where you would create kind of like a securitized token offering, where you'd say, I'm going to create this asset, or I'm going to register this company, or whatever you want to do, is your deed, your title, your metadata, and then you make the owner of that actually owned by the token. And so what happens there is your token balance represents your ownership or your partial ownership in the actual asset itself, so that if there was any sort of debit going into that asset, it would be claimable partially by the amount of balance that you have in that token. So that basically, yes, it allows these tokens to be backed by assets, but then the network to actually enforce the payments happening. This doesn't need any centralized authority to say, oh, well, so now that I verify you have this token, I can verify that you receive this dividend. No, the network itself automates all of that. And it automates the split revenue payments too, other than I think some other projects like Raven or whatever that require a securitized centralized exchange to actually honor the assets themselves. They're acting as just asset recording systems. We're kind of want the network to enforce that as much as possible. So that's essentially how that works, and that's what that's being designed to do. And then the next layer of that beyond just split payments is the actual votes, so that you can actually tally network-wide votes for them. And then a stage after that is the decentralized exchange, which allows you to exchange an asset for whatever token that you want, so that you can essentially put your asset for sale, and you just put a validation script to say, I require this much of this token. And then if somebody transfers that token into your account and flags that TXID to execute that validation script, what's going to happen is that's going to fulfill the true, since they have transferred that amount of token, and you'll be able to credit from that debit, and they will be able to claim that transfer. Or in other words, you create an asset to token transfer that happens automatically on the network, or you can do a token to token transfer. And anybody essentially will be able to create any type of these orders, whether it be asset to token, token to asset. Somebody could put up a buy order to say, I want to buy an asset of class whatever, and I will pay this many tokens, or I want to sell this for Nexus, or et cetera, et cetera. So that's kind of the design of it. It's going to obviously require more disk space, because you're going to have to keep track of these orders, and you're going to have to keep a fulfillment similar to kind of how you saw the notification system working. The network's going to need to index those as blocks come in, so that you don't have to search back and recreate the indexes every time you have a new user switch, or you want to check a new token type. So that's going to most likely be a command line flag, just like we have index height for people. If you want to include more indexes in your keychain, then you're perfectly able to. So to support the DEX is probably going to be a little bit more actual computational requirement, or disk space required. I'd like to think that it's not going to be too much, because it's really just going to be foreign indexes of a transaction to an iterator number. And then you'll be able to just see all of the actual open orders and all of the orders that have ever executed. And then from there, front-end guys will have a fun time actually drawing that into bar graphs and things such as that. Massive pool of data, which will obviously page, et cetera, et cetera. Any other questions? I think we got 6 minutes. Wow, we already burned another 40 minutes. Well, I guess it is good then that we got a little more time to go in depth. On the subject of indexing, can more options be added to improve capability with Explorers? Yeah, we can add any indexing options you guys want. Even as far as like indexing addresses that come in and indexing transactions to those addresses. I mean, it's just going to take us a little bit more time on code, but yeah, I mean, for whatever you guys want, that's kind of the plan, is to make it run on default pretty light on the disk usage. I think our disk usage right now is 30% less for a Tritium node versus a legacy node. I think I noticed the Bootstrap's only 3 gigabytes versus 4 gigabytes compressed. So I think it's a lot lighter. So we want that default mode at least to be light. But yeah, I mean, if you want to add all those things, with disk space isn't a problem. I want to give you those features to add, because more indexes will make it run faster for certain operations you require.
I think, yeah, that was a really good demo, actually. Thanks for doing that for us, Colin. So I think
live demos, nothing broke, which means it shows that it's running pretty nice and stable too. Fresh testnet.
Definitely.
Yeah. So I'm excited. That's next week. It's gonna be fun.
Yeah. So I was just gonna say, so what are we hoping to show next week? Would that be hybrid mode?
Yeah, well, I'm probably not going to do hybrid. I'm only doing that because Dino likes to test in private mode, not on the testnet. But next week, I want to show the actual usage of creating an STO and having a dividend payment, and creating a song and accepting a royalties payment on it, and distributing that to different artists. So, Paul, if you want to do that with me, we can kind of demonstrate it over a live network with you and me running a testnet together. Maybe we do it over Lisp. We can show it in the web browser, which is pretty cool. Even like when I had Jack over there the other day go say, hey, check your notifications. And he went on his phone into a web browser and he checked his notifications right on the network. That's pretty cool. So we'll maybe make it a little more interactive next week and show exactly what Merck's question is about. Can I create have a token backed by assets? We'll show the tokenized assets command, which is not yet implemented just because I wanted to test all these primitives first. As you can see, it takes a while to even run one round of tests. If you get to credit and then it fails there, you got to start all over again. But I feel like it's come a long way. It's feeling really, really solid. Yeah, so I'm really excited. I think it's really, really amazing to see all this architecture start to come to life a lot more. And start playing with all these things instead of just be building. Right now we're at 68,000 lines of actual raw code, 130,000 including comments and spaces. So I know Paul will say, "Oh, that's not much compared to what he's worked on," but it's some pretty code all the way down. So I gotta say that I'm proud. I'm proud of us. I mean, the last time I think we had a code update, I think we've done about 40,000 new lines. We're averaging, I think, 400 or 500. Oh, and I think one last update, the encrypted pointer. I don't think I mentioned that. So when you log into your account, the actual memory that stores your login information is encrypted in memory, which basically means if you have a virus on your computer, they can't even read the memory and find out what your SigChain username and password is that way, which is pretty cool. It's using AES 128. So the LLC, if you look at the code, the LLC's got a lot of new fun things in there, such as Argon 2, Falcon, AES, and the LLC is meant to completely make us not need any sort of external dependencies, which our only dependency we have right now is OpenSSL.
Brilliant. Okay, well, we got 2 minutes left on this recording. So I just wanted to close up by saying that we are, as a development team, are going to try and create some examples based on the demos you've just seen. So, creating an asset and tokenizing that and all these kind of demos that are being done, we're going to try to document those so that it's easy for other people to try them out. We'll be doing those over the next few weeks. Because I think we're at a point where people can now start playing with it and they want some demo code there available so they can just copy and paste it and try things.
Yeah, maybe we'll do like some web interface code. Maybe next week we'll show like a login page and how that works, just going through a web form. And add to that, all of the documentation for everything we've done is there on GitHub, documenting exactly what parameters are required and what you're going to get in return. So if you're a developer and you're interested or you're on the public test net, just feel free to play around with it. And if you get any bugs, obviously report them to us.
Perfect. All right. I think we'll wrap up there then, yeah?
All right. Yeah, sounds good. I guess we'll upload part 1 and part 2. We'll see about getting mine on YouTube. And I think Alex should get his on BitTube. And yeah, you get both of them, Alex? Yep. All right. Well, thank you guys. And we look forward to next week's demo and continued code updates.
Thank you, everyone.
Thank you.